Awesome. So welcome everyone to February's Kitchener-Waterloo Video Tech Meetup session. Today we're joined by Behnam Kakavand, who's the lead video R&D engineer at Evolution, and he's going to introduce us to the encoder evaluation suite project and that assists in evaluating encoders. So Behnam, take it away.
Thank you, Christopher. Hi, everybody. Thank you for joining me today. My name is Behnam, and today I'm presenting our encoder evaluation automation suite. Basically, we are calling it EASE to you. Quick word about me. My name is Behnam. I've been working with the video stuff, online video stuff since 2010. Been almost to every kind of use cases from the VOD, the live, everything. Right now, I'm the VDR and the lead engineer at the Evolution. Evolution being the largest provider of live casino in the world, being active since 2006, previously known as Evolution Gaming. And right now, currently, we are operating more than 800 live studios. That means live streams coming from all of these studios, and we are operating globally 24/7. And today, quickly, what we are going to talk about. What do we mean when we are talking about evaluating encoders, and why and when and how we should evaluate our encoders. I'm going to introduce the EASE tool, and for just sake of some information showing how we did it, I'm going to present some of the findings that we had with using the EASE, with the help of the EASE, mainly with the SVT AV1, but not just that. We used basically tested almost all closed and open source encoders out there, and hopefully a live demo as well. So when we are talking about evaluating encoder, what do we mean exactly? What are we going to evaluate? The goal is actually to evaluate the encoder behavior. That means the speed of the encoding, the resource usage, the output quality, of course, and compression efficiency. How well does it work when it tries to compress the video based on the use case? And the behavior is highly related to the content and the use case. In our case, it is low latency live streaming. In your case, if you are doing with the VOD, it's completely different thing. Encoder latency, again, low latency live streaming latency is a crucial part of that. And we have to measure any encoder that cannot keep up with low latency requirements is out of question. And various encoder features that we are evaluating, things like different modes of encoding, like constant rate factors, like the variable bit rate, constant bit rate. And these aspects of the encoder, these features of encoder can be very important for your use cases. Why do we actually evaluate audio and video encoders? Well, the main goal is that to basically identify the best encoder and encoder settings. And we have to identify bad behavior whenever there are huge spikes in the bit rates, huge degradation in the quality, or encoder is simply lagging behind speed-wise. We have to be able to evaluate and identify these cases. And bad encoding, we all know that we have to fight with all of these symptoms that starting from the bad encoder, downstreams in the playback, in delivery side, everywhere basically. A badly encoded video will be bad everywhere to deliver and to have playback. And we would like to basically identify what would be a good encoder, how can we tune an encoder to behave goodly, and a good behaving encoder will optimize your cost. You don't have to deliver unnecessary bits over the CDN, and CDN costs are not cheap. And of course, good encodes will enhance user experiences. They don't have to drop the quality to lower quality streams just because of the spikes in the bit rates, for example. And if another case would be if there are new hardware or software encoders out there and you would like to actually evaluate them and see if they will work for you, you have to you have to evaluate the behavior again. And if there is a new codec, as it's been a talk of hot topic over the years, past few years, you want to understand how it works, and you have to do an evaluation again on those encoders as well. A quick example of an exaggerated badly behavioral in the encoder, you see that the bit rates are fluctuating. The green one, the top one, is the topmost one is the HD. The yellow one is 720, 640, 486, 360, and the lower one. And you can see that the bit rates are actually fluctuating, going very wide. They rise. I mean, it's supposed to be on average 5 megabits per second, but it goes almost as close to 8 megabit, 7.5. And the drops of for the HD below 2 megabits per second. And you can see that the bit rates are actually overlapping. That could cause problem for users. And just an example of the problem that it could cause is that when the bit rates drop that widely, the player may mistake it and think that it already has enough bandwidth to switch to higher quality, whereas that's only a temporary thing, and bitrate will go back up again, and there could be freezes and bad player experience as a result of such fluctuations, and it could cause the increased latency in encoding as well. A very well behaved encoder, again, it's an exaggerated one. You can see that the bit rates don't have any collision together with different qualities. There are jumps, of course, but not as high. And of course, we can see that the difference between for example, the orange and the green ones are too much, but it was just for the sake of presentation. In practice, you never have a stream at 1 megabit per second and the second one at 2.5 times that one. But you get the idea. And an encoder that actually behaves like this means that it most likely will have a very predictable latency, and that's good for player as well as your stats as well. And when should you actually evaluate your encoder? Of course, when there's a new content, that might not be the case for services that are dealing with the content, user-generated contents, for example. Some services like YouTube will never be able to evaluate their encoders based on each and every one of the contents that are uploaded to their services. But in our case, we have total control over contents. We are producing our own streams. So when there's a new studio comes, new game comes, we actually go and evaluate our encoder settings to have a very specific, to come up with a very specific settings for that specific content. Other times that you might need to reevaluate your encoder settings are when there are problems, when you see on your stats, actually there are increased buffering, there are rising number of playback failures and stuff like that. It might be a time to go and check your encoders again and see if you're doing the best you can with your encoders. And when there's a new market, for example, there are emerging markets joining in, and they are big topic for everybody in the video streaming and internet industry, basically, that they are joining, and start using internet services, internet video more and more, but there might not be the best infrastructure in those markets yet. So you have to adjust again your encoders to have to create more smooth experiences for the users in those markets. And then if there's a new technology, if there's a new encoder or new codec, AV1, for example, is a hot topic, or an encoder that does whatever the new codecs that you are using in a new way. For example, if there's a new hardware or software encoder, then you want to try it and see if it works well and how does it work, and that bears an evaluation. So how do we evaluate? This is a hypothetically not so hypothetically, it's an experience. How did we actually evaluate our encoders previously? Well, first, again, this is very specific to our use case. Since we have the control over our content, we would start by watching the content, watching if there's a new game, new studio, trying to see what's happening there, how much motion is there, how is the lighting, how are the textures, and try to identify the type of the content. Is it a complex content? Is it not? Is it how are the movements? Are the movements vertical or lateral? And start with a guesstimate that I said, a rough encoder setting. But in reality, in our case previously, we already had many studios already in play and been used. We tried to mimic or copy from a similar content first, and then go around and start creating different qualities, 4K, 2K, HD, 720, and so on and so forth. And after that, start measuring the quality using the VMAF, PSNR, or whatever uh, uh, quality metrics that you would like to use. And then watching the compressed file, it was very important for us to see if we see a VMAF certain VMAF score, let's say 80, 81, but you wanted to see actually how does it look to your eyes. And then, if needed, start modifying the encoder commands or parameters and repeat everything again. This image, you can see that is taken from YUBU, another open source project. And you can see that on the top one, it tries to show one of our studios, first the real studio, the actual studio. This one uh, shows the spatial complexity. What are the parts that create the spatial complexity? And this one actually creates uh, tries to showcase the motion and temporal complexity of the video. And the second one, again, the same thing. You can see that in the spatial part of the thing, all the textures are creating is showing up in the brighter the color means that there is more energy in those parts, and in this one only the moving will generate the temporal complexity. So the challenges of this approach is that it's actually very time consuming, and it is highly repetitive. It requires a lot of patience from the tester, and it requires trained eyes to see what's going on. If there is a certain number score that you see on the quality metrics, what does it actually mean? You have to watch a lot of videos actually, basically, to be able to correlate them. And then it requires experience to choose the best parameters to tune to get a better result. And yeah, better understanding of inner working of codecs always works. So you know that whatever that you're, what is it that you're actually adjusting? Otherwise, you have to do a lot of work, a lot more, to be able to find out which parameter will help you the most. It's also very resource hungry, as encoding is, of course, is. So therefore, to alleviate some of these issues, basically we developed this tool calling it Ease. It's actually a wordplay on encoder evaluation suite. It's developed by my colleague at Evolution's R&D in the video team, Yuri Spune. He is right now in Riga, Latvia. Because of the timing, he could not join us in this meeting, but he's always happy to answer your questions. It is an open source tool. It's a command line tool written in Go, currently only working on Linux and Mac. And what it does, it actually automates multiple rounds of encoding. It can create batch encodes for you and automatically generates the VQM graphs and numbers and reports. And therefore, you can basically just, instead of watching all the video files, you can just go and check, and the ones that actually creating a acceptable range of video quality metrics for you. So you don't have to go through all the encoded results. And you can, it gives you the ability to perform it remotely. I'm doing it on our more powerful encoder machines instead of doing it on my laptop all the time. And it also is very helpful in understanding the behavior of new codecs and getting to know them faster and spending less time. But it still requires human to design the encoding plans. And the link to the GitHub public repository is also there. And how does it work? Actually, you have to build or install it, or pre-built binaries also available on the GitHub. And what you should do, you should create an encoding plan, which I will show you a little bit. And you have to run the encodes with that command, just is run, giving it the plan and giving it an output directory. You can get help, of course, and see with is run -h, you will be able to see the parameters, what is available to you. But it's pretty straightforward and simple tool, so to say. This is a sample encoding plan. You can see that there are two inputs, clip 01 and clip 02. And there are schemes, we're calling them schemes, and each one has a name and a command tuple. And basically, it will go and through the input files and applies and runs these commands on on all of those inputs, meaning that it will generate, in this case, it will generate 4 output files, one for in 1700K for the clip 01, and one 2000K for the clip 01, and same for clip 2 as well. And it will create all the directory structures and everything for you. An example of how we did actually use the is in evaluating the AV1 encoders, because we are, like everyone else, looking after, we have to think about the cost, delivery cost, and everybody wants better quality. So AV1 seems to be the way forward. So we went out and tried to get our hands on every AV1 encoders available out there, closed source, proprietary, and the open source ones as well. And I'm going to present some of the results that we found we had using the ease, basically. And our goal was to find which AV1 encoders are working best for our case, which is low latency live streaming. And the encoders that we tested so far are among the free open source ones, of course, libaom, that's the reference implementation, the Ravi, and SVT-AV1. And among the closed source, there are two, Visionulars Aurora 1, which is a software encoder, and you can run it with the FFmpeg, and it's excellent. Actually, it's a great software encoder from a great team. And the other one, the Netins T2A Quadra, which is a Canadian company, and it's a hardware encoder. It's also a very interesting encoder that right now we are testing, one of those hardware encoders that actually can receive updates and can basically adjust their the commands and the encoder performance over time. It's a great product, but because for the sake of basically keeping up with the open source spirit, I'm going to talk mostly about the open source ones that we did. And the key elements in our testing were speed, of course, low latency live streaming. So speed is the first thing. If an encoder does not produce in real time, the output in real time, it's out of the question for us. Quality, of course, using the PSNR, SSIM, and VMAF scores. And the other very important aspect, which is behavioral aspect of an encoder, is the proper bitrate control. If an encoder basically have very wide fluctuations, big jumps and big drops that won't be usable for us, and in our case, for the live streaming, basically. So I'm starting with the libaom. The version, the last time we tested it, the latest version at that time was the version 3.220, and I'm not sure what is the latest version on that, but it was actually pretty much capable of creating live encodes at this speed, even more than live speed, up to 26 to 32 FPS. And but the problem with the libaom was that actually the rate control modes are just not working with in live, and you could see that it's overshooting the target bitrate by a huge margin. Uh, The average bitrate usually goes around twice the amount that we actually specified. That makes it unusable for us. This is a graph. I'm not sure if it is very visible on your screens or not. It's readable or not, but quickly is that in the left column are the bitrate control mechanisms that we use, the modes, the both constant bitrate, constant quality or quantization, and the variable bitrate. And you can see that from the titles here, for example, for the 1800K in variable bitrate, it jumps very high, as high as 3214, or in the constant quantization, you see that for the 2000K it goes as high as 3477. So basically that makes it very unpredictable and not very usable for in our case. I'm not sure for whose case it actually will work in live mode, and I don't have much information on the VOD and pre-recorded one. But yeah, the quality was not bad in that case. And these are the libaom's quality metrics. Actually, you can see that on the left side, this is our standard. I mean, the reference encodes using the libx264 at 3 megabits per second, and you can see that the VMAF score on average is around 85.714, whereas in the libaom in VBR at 2.3 megabits per second, it is a lot higher than that at 93. And you can see that the majority of the VMF scores of the frames are a lot higher than what it is on the libx264. And in CBR form mode, basically, it's the same story. But it's a shame if it was any good at controlling the bit rates. Maybe one of the reasons that actually it has some such good VMAF scores are those high bit rates, because of course it is in name only VBR at 2300 kilobit per second, but in reality it is a lot larger than that. The next one that encoder that we tested is the
Behnam,
yep.
there's a question in the chat. Abdul
Sure.
asked if the lowest point is also lower in case of libaom. Why do you think that is?
Could you come again? The
The the lowest
lowest.
the lowest point is also lower in the case of libaom.
Okay. Well, the thing is that libaom, as I've been hearing it time and time again, should be considered as a reference implementation, not something that you are going to use it in production. So I cannot fully trust, I mean, the libaom's implementation in this case. So if it goes as low as that, then it is just, I can see these numbers here we're talking about, I guess. And it is some of the symptoms of, I guess, not so very optimized code in there. Otherwise, it's not the problem of the AV1, but the implementation in the libaom. So I cannot tell what exactly went wrong there, because to be honest with you, when we see that the fluctuations are so high, it didn't bear any more, I mean, it didn't worth for us to dig any deeper into that. So that's that may not be the exact answer that you were looking for, but yeah, I mean, it is all related to the how they implemented the libaum. Hope that
And
answered your question. Yeah.
there's a follow-up question that the VBR and the CBR scores are kind of similar. Is that
True.
just because the rate control you think is just not good?
Yeah. True.
Yeah.
True. True. Yeah. Okay. Ravi. Ravi, actually, the worst thing about the Ravi was the speed. It's just at that version. I don't know about the latest versions or how many updates and cycles have been after that. But at that time, which is about a year ago, it was not it was not simply meant to be used in live. Even though there was this real-time mode, you can see dash dash low dash latency. uh, it's just not fast enough. But rate control is actually pretty good. It creates a very consistent bit rate for almost anything that we throw at it. But the trouble with that is that it looks like that sometimes it actually have to uh, go overshoot by some margin to be able to create something that is usable. Otherwise, the visual quality will drop huge and hugely, and it actually did happen. And there are not at that time, again, it may be a different case right now. At that time, there were not many tunables, not many knobs, so to say, so we can actually play around with it, see if we can get anything better than that. So, but you can see here are the bitrate control. In this case, at 2000K, the average is around 1999.61 is actually pretty pretty close to the 2000, almost the same. Or in this case, for 3000K, it does 2998.99. So it's almost exactly. It looks like it's trying so hard to keep up with that number, even though it may need to go a little bit higher than that. And you can see that actually the VMAF scores sometimes drop so low. And you can see that the huge pile of lower VMAF scores are here, and some of them are close to zero, very close to zero. And this is actually what's happening when it is going that low. It's really bad. So Rabi was also out of question. Now we get to the SVT AV1, the most promising open source encoder, AV1 encoder out there right now. And we've been testing it since many versions ago, but starting from the version 1.1.0, the SVT AV1 can actually encode in real time, especially on a processor with the AVX2 or AVX512 available to it. And the AVX feature of the encoder actually helps a lot with reducing the load on the CPU. And that's a great thing. And this could help it actually increasing the encoder density, meaning having more streams on a single machine. And it has many parameters to play with. It can create multiple basically modes of encoding, constant quantization, CRF, constant rate factor, constant bitrate, variable bitrate. It has all of it. And it has multiple different quality and speed presets. And of course, the presets means a set of parameters that you could actually go and play around with them as well individually. And both the CQP and CRF rate control modes actually create pretty good result quality-wise. But there is an issue with it, and that is the latency. Of course, you can see that it can generate like, for example, a 30 FPS live video, but the latency, meaning that how long will it take for a frame to get basically compressed as soon as it is entering the encoder until the time that it's actually being produced on the output, it's still a long time, and it's not usable for us. In this case, an average of 514 milliseconds. And on preset 12, which is supposed to be the fastest one, there is a preset 13, but they are not recommending it. It's it's not usable in quality wise. But
There's
for yeah, go ahead.
sorry, there's a question. Is that 514? Is that end to end? Like you're measuring before it goes into the encoder or after, or is that the frame latency?
It's as soon as it's arrived on the encoder machine, and it goes through the encoding and the compression, and we are receiving the output on the output of the encoder before
Okay.
packaging. Yeah.
Okay.
And for us, when we are trying to basically shave off every millisecond on our low latency live, because there's an element of interaction in our case between the game host and the players, 500 and half a second is just way too much. So only for that reason,
Sorry,
it's not
what's
possible for us.
X264 latency you have seen? What's the most optimized latency you have seen? As that would be the target for you, right?
True that. Well, actually, that's a very good question. Regarding the libx264, if you're just using the libx264 on its own without being wrapped around with the FFmpeg or the AVConv or whatever else, it's actually pretty fast in low latency mode. Without using any B frames, we actually can see that the latency is around 7 milliseconds up to 20 at most. It's very, very fast. But if you are using something like the older versions of the FFmpeg or AVConf, for example, there will be huge added latency to it, but it's not actually the libx264. If you can fix that part, it's actually very fast. And yes, we understand that we may not be able to achieve that time with software encoders, because if you are talking about the new AV1 new codec, the way that we are achieving those bitrate saving or added quality is by spending more time processing it with more tools, a lot more tools. So it makes sense to have a slightly higher numbers. We don't think that with a software AV1 encoder we can achieve numbers like that, 20 millisecond, but we don't expect it. But something like 80 millisecond, 100 millisecond would be more acceptable. But 500, like half a second, is definitely out of question. And yeah, regarding the bitrate control, how does it perform? I mean, actually, the data sets that we have out of these encodes are huge, and we are working to publish them on our tech blog, in the Evolution Gaming's tech blog. But for the sake of the time, saving the time, and I cannot go through like 40 different graphs, I'm just presenting few of them here. In the SVT-AV1 version 1.4.1, which is the latest version at preset V12, in VBR mode at 1800 kilobit per second, comparing it with the libx264, you can see that the reason that I chose this bitrate to show the graph is that because it created a visual quality closest to the libx264 at 2.3 megabit per second. And you can see that the bitrate control is pretty, I mean, it makes sense, it's pretty good. There's no huge jumps to up to, I don't know, you see that at the maximum is around 2.5 megabit per second, or even less than that, 2.3 actually, and it's manageable. It's pretty usable. And regarding the quality scores, you can see that now more frames are on the higher side of the VMAF scores compared to X264. Of course, there are huge drops happening here, but it's just for few frames. And it's not a deal breaker. It's pretty good quality. And I'd say that it's even better than the X264s. And sorry. So yeah, SVT-AV1 is a pretty good software open source encoder, but not for low latency live streaming yet. Actually, we've seen that in the latest version 1.4.1, the average delays are actually going a little bit higher than it was on the previous version. So still, fingers crossed for the next basically iterations, but they themselves, the developers themselves, that saying that live streaming, especially low latency live streaming, is not a target for the SVT team for now. But let's hope that will change in future. For this part, I'm trying to have a live demo and hope everything goes right. As live demos are going, 100% of the live demos are always going in the right direction. So I guess I have to change and start sharing different window, right?
Right, as you do that, just a quick question. The last graph that you shared, majority of the frames are lower than 90. And on a VMAP scale, because it's such a nonlinear metric, less than 90 is not ideal. Even less than 93 people say is not good. So are you picking why these bit rates if the quality is not at the level that you want it to be?
Well, as said, it's again highly dependent on your use case. In our use case, of course, I agree with you. It is not the ideal quality that I would like to see, a crisp video, but there are sacrifices to be made. I mean, for example, one of the reasons that we are doing in our current encoding is that we cannot use B frames for many reasons. We are doing high profile on the H.264, but we cannot use B frames. And we know that the B frames are actually the beat savers for you, but we cannot use them. And so what I'm saying is that we have to make compromises for our use case to be able to have acceptable quality. Acceptable is the important thing here, to our customers, to our players, without it looking like the for example, Zoom calls. It has to be good, but it definitely is not as good as something that you may watch on Netflix or on a sports event on broadcast TV. So I'd say that in our use case, these VMAF scores are acceptable for now. That may change in future because people are getting more used to higher qualities. So we have to think about that as well. And that's something that we are working on too. Hope that makes sense.
Yeah, no, understood.
Okay, let me share my other screen now. Can you see it? Hope you can. All right. First, this is the command that I showed you. Simply is run dash plan. This is the plan's basically path, and I give it a output directory. Let's quickly see the plans. It's the same demo one, as you can see. For this case, I chose a 3-second video only because VMAF scores measurements are taking time. And in the interest of time, I'm just creating a 3 seconds video and sending it through 2 sets of encodes in the libx264. Nothing very fancy. And yep, that's that. So let's run it. And if we take a look at the demo, you can see that it starts to encode video, gives you all the logs, what is it doing it right now, and it creates, sorry, you can see it creates all the output. It creates the log file. Everything that happens, you can find it in the log file later. For example, one of the things that I found out was that the SVT-AV1 shows an average and maximum latency value in the log file, and we found it over there, not in the actual encoder basically process. So we are not yet creating any graphs or reports on that. You have to just go manually and extract that information. So that could be a good change or possibly a pull request for somebody to add it. And you can see again, if I'm going to show you this one, for example, you can see what's happening here. See that these are the files that it's creating out of the all of those graphs are in the PNG format. And yeah, and there is this VQM JSON, everything is there. And yeah, let me just quickly show you the content of the one of these JSONs. Gives you all of the VMAP scores and uses this same information to create all of those graphs. So yeah, nothing went wrong this time. I'm happy about that.
Is there, I don't know if you mentioned it earlier, but was there a way to like farm it out if you were doing several hundred encodes over a large, like a farm, or is it all kind of, you just have to scale horizontally instead, or vertically instead of horizontally?
Well, the way that it works right now, it actually goes through each of those commands one by one and
Oh, I see.
basically runs them. And the way it's the best thing, what I'm doing right now is basically I formulate all of those plans and input files and just run it and come back to it the next day. That's usually it'll take a long time, but that actually could be a good suggestion for the improvements and the feature over there, that you'll be able to run it on a farm. So the final words, any questions, comments, and contributions are highly welcome. And in the spirit of talking about the open source stuff, and I believe that it's all of us in the online video streaming industry owe a lot to open source projects like the MPEG, AVConf, libx264, 65, VLC, GeoStreamers, well, you name it, there are so many of them. I just wanted to ask you to please help these guys. I mean, these are some of the, especially people are working on these projects like the FFmpeg, like libx264. So not that they need my mentioning, but these are some of the best engineers in the whole world. So hire them, consult with them, contribute to their projects, and if you can, donate to these projects. And they've been very helpful to all of us. So questions and comments are welcomed.
Yeah, anyone? We had some questions during the thing, but yeah.
Okay.
Is there any, I guess, improvements that you want to add to it?
Right, but actually it went through rounds of improvements not very long ago. Previously, you had to specify a lot more parameters to the command line for it to work, and there was a separate stages for encoding and the quality metrics measurements. URIS has combined all of them together. So right now, this is the latest that we came up with. One thing that you said, being able to making it work in parallel, that would be a great improvement. Any other ideas are highly welcomed. Of course, the repository on GitHub is public, and you can leave your comments and questions over there as well.
Awesome.
I have a question. Then, like, you mentioned something about dataset. Like you want to make it public. I just wanted to know, like, whether that dataset will be only related to the gaming thing, or it is more diverse and includes different content types.
Well, the thing is that all of our data sets, yes, as you said, it is very specific to our own use case, and we ran all of these on our own use case, which, to be honest with you, have some, I mean, specifically our competition, they are also very interested because they are working with a very similar type of content. But I can imagine if you're talking about live streaming, especially low latency live streaming for whoever is using them, we chose specifically a type of games that we are basically having, different types of games. One of them has very high motions, unrealistic virtual environments, animated and stuff. The other one has real studios. So it covers a large portion of use cases, but in the realm of low latency live streaming, because all of the encodes and encoding plans that we created uses the parameters specifically for this purpose. So yeah, it covers a big portion, but not everything.
Okay, sounds good. Thank you.
Sure.
Okay. Well, I'll let people who are still on go. Thank you, Behnam. Thank you. That was a great talk. Thank you everyone for joining,
Thank you.
and yeah, I'll see you all next week, or not next week, next month. All right. Thanks, everyone.
Thank you.
Take care.
Christopher.
Thank you.
Thank you, everyone.
Bye bye.
Bye.